So, you've probably used the words electrical and electronic, like they're the same thing, right? I mean, we all have. A phone charger, a lamp, a TV, it's all just electricity, isn't it? Well, yeah, kinda. But there's this really cool fundamental difference between them that, once you get it, is actually pretty fascinating.
So, what is the real difference? I mean, why is a simple toaster in a completely different ballpark than, say, a tablet? That's what we're going to tackle. And trust me, in just a few minutes, we're going to break it all down to one single core idea that's probably going to change how you look at pretty much every gadget you own. All right, you ready? Here's the secret sauce. The entire difference, the big aha moment, it all boils down to just two little words: power versus information. That's it. You can think of it like this: one is all about brute force, and the other, it's all about the brains. So let's start with the muscle. That's electrical. This is all about the heavy lifting, generating huge amounts of power and just moving it from point A to point B. We're talking high voltage, high current, the big stuff. But electronics, that's all about finesse. It uses just these tiny little sips of electricity, super low voltage, low current, to do something much more delicate: manage and process information. Okay, let's dig into the purpose of each. An electrical device, it has a really simple job. Its whole goal is just to transform electrical energy into something else. Light from a light bulb, heat from a toaster, or motion from a fan. That's it. But an electronic device, oh, it uses that electricity for a way more complicated task. It uses it to process data, to send messages, basically, to think. So if you want a neat little summary, it's transformation versus computation. Okay, so that's the theory, right? But how does this play out in the real world, with stuff you actually use every day? Let's dive into some practical examples to really make this idea stick. First up, let's talk about things that are purely electrical. The main thing to remember here is that their one and only job is to convert power into a different kind of energy. There's absolutely zero decision-making happening. Okay, think about a simple electric motor in a fan. What does it do? It spins. That's it. It's just turning electricity into motion. Or what about an old school light bulb? The kind with the little wire inside? It's just a filament that gets super hot and glows when electricity passes through it. It's pure, simple energy conversion. Same goes for an electric heater, or those huge gray transformers you see on utility poles. They're all about one thing: handling raw power. No thinking involved whatsoever. All right, now let's flip the switch and talk about electronics. These guys are a whole different beast. They're all defined by their ability to manage data. You could say they all have a brain, even if it's a really, really tiny one. I mean, your smartphone is the ultimate example, right? It's basically a tiny supercomputer in your pocket, constantly juggling information. A modern TV isn't just a glowing box. It's actively decoding this super complex signal to create a picture and sound. And get this, even a simple radio is electronic. And you might ask why? Well, because its main purpose isn't just to make noise. Its job is to intelligently sift through a sea of radio waves to find and pull out one specific audio signal. See? It's processing information. So there we have it. Power on one side, information on the other. Sounds pretty clear-cut, right? Well, here's where it gets interesting. In the world we live in today, almost everything you use is actually a hybrid. It's a mix of both. Let's take your air conditioner, for example. You've got that big, heavy compressor motor outside, right? The thing that does all the hard work of cooling the air? That's the electrical muscle, pure power. But what about that little thermostat on your wall that's reading the temperature and deciding when to kick that motor on? Ah, that's the electronic brain. It's processing information, the room temperature, to make a decision. A modern car is an even better example, actually. The starter motor that cranks the engine to life, the alternator that keeps the battery charged, that's all old school electrical stuff. But the ECU, the engine control unit, which is basically the car's central computer, and all those sensors plus your fancy infotainment screen, that's a super sophisticated electronic network, making thousands of little decisions every single second to make sure your car runs just right. And this whole hybrid thing applies to even the simplest devices now. Take an LED light. The little diode inside that actually makes the light, that's a simple electrical job. But the moment it becomes a smart bulb, well, that tiny circuit inside that gets the signal from your phone and tells the light to dim or change color, yep, that's the electronic part. It's processing your command. So look, if you walk away with just one thing from this, let it be this simple question you can ask yourself. Is this device's main job to move a bunch of power around or turn it into heat, light, or motion? If the answer is yes, it's electrical. But Is it using electricity to think, remember, communicate, or make a decision? Then that's electronic. It's honestly the easiest rule of thumb you can use.
And that kind of leaves us with a cool thought to chew on. As we keep adding smart features to literally everything, from our coffee makers to our doorbells, what do you think is the next classic, purely electrical device that's going to get an electronic brain transplant? It's kind of fun to think about, especially now that you know exactly what to look for. Thanks for joining me on this one.